be talking a little bit about the research that I'm doing at CU. So the talk, it's like how we're using network science tools to analyze cities. And first, a little bit more about myself. I have a background in architecture, and I was interested since studying architecture in analyzing cities and to understand cities and their infrastructure as networks. Even though when I was studying architecture, I haven't had any formal interaction with network science. I had somehow the intuition that probably we can start modifying, or we can start analyzing the city like with different layers, and to start analyzing what's going on in the city. And at the same time, I'm very interested also in how can we start building from the city and from this analysis into the public policy processes, because at the end, if we want to modify the city, then we also have to engage into the public policy processes. And so I worked for a state government for a couple of years, doing some public policy planning for bike shared systems. And then I moved to do network science PhD. That's where I'm now. I have no idea what the future will look like, and if we have learned something into 2020, it's that the future changed a lot. So let's see what it goes. But so the first project, it has to do with some bicycle algorithms. And in this one, the main idea is to analyze the city as a network where we can have each one of these, each one of the intersection map as a node, and each one of these different streets or sidewalks or public transportation infrastructure as one link between intersections, or one link in this network. And if we map the city in this sense, then we can build actually a multiplex network. And this is the example of Manhattan, where we have the multiplex network of the city, and then we start analyzing each one of the layers and to understand what was going on behind each one of these layers, or in each one of these transportation systems. And so we have another project also on the multi-layer aspect of the city, but I'm not going to talk about it today. I'm going to talk mostly on the bicycle layer. And for the bicycle layer, we start realizing that it's the most fragmented layer in the system. So it means that it has like a bunch of different sub-networks all around the place, and they are not very well connected. So the idea was, can we start connecting them together, and can we start analyzing what's going on with the bicycle infrastructure in the city? And we can see like this example for Copenhagen, that even for Copenhagen, one of the most advanced bicycle cities in the world, they still have some patchy infrastructure going on. And in London, they have more than 3,000 different sub-networks, bicycle sub-networks in the city. So how can we start improving the situation? So of course, I had to check if what the data was telling us was right. This is a picture video from Budapest. And yeah, there are some places that the bike lane just go into the sidewalk, and that's it. Even though like, I don't know, 20, 50 meters from that point, there's another bicycle lane. So it can be quite easy just to put, to complete the infrastructure. So the goal was to design some algorithms to find these missing links and to start proposing where we can start building new bike lanes. We designed two main algorithms, so largest to closest. This means that we look for the largest connected component in the network, or the largest bicycle subsystem, and we connect it to the closest bicycle lane that we have, and so on. And then we have the largest to the second, so we look for the two largest connected components and we link them together, and we keep repeating this process. And we compared our algorithms with two approaches. The first one, it's a closest connected component, so we look for all the possible connections, and we start connecting the two closest together. So it's like a minimum investment approach.
Sorry, what is L2C in your case?
L2C, largest to closest.
Okay.
So it's from the largest connected component to the closest one. And then largest to second, so the two largest, and closest to closest. And we have a random approach. So randomly we pick one component and we connect it to the closest that it has. That's like, yeah, like if we start just investing randomly. So this is a simulation of the Budapest case. And in this one, we start noticing that with just a little investment, less than 20 new kilometers of bike lanes in the city, we can connect mostly, like more or less 65% of the whole system can be connected in just one giant component. So the idea was okay, we designed this, and then how can we test this to another city? So at the end, we ended up with one complete network. So it's everything is connected, and we can cycle along the bike path all the city. And we applied the algorithms to different cities around the world, because actually we were also interested in, okay, we have a lot of data for cities like London, Manhattan, and some European cities, but how can we apply this kind of methods to some cities in the global south? So the idea was to apply this to some other cities, and we can see that for some cities like Bogota in Colombia, if we invest 5 new kilometers of bike lanes, we can move from having a little less than 25%, around 25% of their connected component to almost all the links connected, almost all the bicycle layer connected. I'm gonna go fast on this one because I also have some other projects, and I'm running a little bit out of time. So anyway, then the next project that I want to talk to you, it's this one is called Life Quality, and this was an approach made with the municipality of Budapest too. In this one, we were asked to measure the quality of life in the city and to start thinking about how can we measure it and how can we improve it. So the idea was, of course, to measure the quality of life can be quite difficult because we all know that it's something very subjective. So our approach on this one was to measure the accessibility in the sense of the pedestrian accessibility. So how easily we can reach certain amenities along the city. This was, as I said, a project in which we worked directly with some experts in different areas. Some politicians were involved, also different stakeholders, and the main goal was to have something to provide some data-driven public policy for the city. So we analyzed the city using 3 main attributes: the pedestrian network, then the different amenities. In this case, I have shops here, and some cities attributes like pollution or environmental factors. We measure the accessibility to these different amenities and the safety indexes along the city and the environmental indexes. And we were trying to answer these kind of questions, like how important is the amenity? So working directly with them, with the experts and the stakeholders, we rate the different amenities or different types of amenities, how important they are. How many people does the amenities being shared with? So we have the population data, and then we can assign like how easily some people can reach each one of the amenities, and then compute how many people are shared the amenity with. And so how long does it take to reach the amenity? Just computing the shortest path to get to each one of these. And then at the end, we ended up with some life quality index for the city. And because this is, we're using the network of the the pedestrian network of the city, then we can capture the quality of life by each one of the nodes. So in each one of the intersections of the city, we can have the quality of life. And then we can start, of course, aggregating these ones in like different political boundaries, like let's say neighborhoods and then districts and so on, and start realizing that even for some things that they have to be by law evenly distributed along the city, like the family education, let's say schools, they have to be, there has to be different schools in all along the city. The best neighborhoods to live in Budapest with family education, not surprisingly, are the richer areas in the city. So that helped the city to start planning and to start thinking about like, okay, if we want to actually address the issue of education in the city and accessibility to schools, then we have to start doing something. The same, sports is a little bit better, but culture, it's completely centralized in the city. And we measure our results with we scrape some data for real estate data, real estate prices, and then we saw that there's some correlation between the real estate prices in the areas of the city with these kind of indexes. So it means that the market is also reacting to what's going on in the city, and that the methods are capturing what's going on with the city. And the last project, and this is something that we have been working in Mexico regarding during the pandemic, is to measure, to take somehow the idea of this idea of accessibility, but how can we start analyzing the urban form and understand how the urban form relates to the accessibility to different amenities during a pandemic. So let's say how easily can be to reach some food options, supermarket, and so on, depending on how we are designing the cities and what's the urban form in the city. So let's take, for example, this kind of areas in the city. In this one, we have some city blocks that are a little bit smaller, and the people can walk along these ones. And then we have some other closed gated communities that if we have some people living in this cul-de-sac and he or she wants to go to visit their neighbor in this one, they have to do all this way, or they want to go to get some, I don't know, imagine we have a pharmacy here. If they want to access the pharmacy, then they have to walk a long distance because there's no permeability in the city. And then we have this kind of also super big, and this is interesting because I haven't thought about it. When Luba was presenting the introduction and the 1960s books from Le Corbusier, and I start thinking also about the examples in Brazil. And when they start planning the new cities and they start building these super huge blocks, and of course they are designed to be livable by cars and not by people. And this is something that is also happening in this kind of urbanizations. And so we measure this accessibility to different amenities, specifically to 3 types of amenities, because that's what we were interested in during the COVID situation, to supermarkets and food options, pharmacies and hospitals. And this is an example of the metropolitan area of Guadalajara in Mexico, where we're measuring the average distance to a pharmacy. And we can see that, yeah, the city center is quite good. This area over here is one of the richest areas in the city, and the accessibility in this part is quite bad. And this is because most of these areas are closed gated communities. So it means that they are, if we're measuring accessibility in terms of pedestrian accessibility, then we're designing some cities that are being car-centric cities instead of designing cities that are promoting a more walkable and livable life. So now with the team, we are working on building a web page to display these results and to start communicating also some of these ideas and to move a little bit from the academic background, because this was developed also with a university. And we want to approach that more to public policy officials, stakeholders, and the broader public. So we're designing these communication tools to start talking and engaging with multiple people around these key issues. And of course, yeah, this is all of the work that we are doing. It's something that I'm not doing it alone. So I'm happy to have amazing collaborators. And if someone is interested into going more into the details, we have these 3 different papers that are the ones that I talk about today. So yeah, thank you. And I'm happy to keep with the discussion and answer some questions.
Yeah, thanks a lot, Luis. Thanks. Are there any questions? Meanwhile, you can actually make me a host back so that I can let the people in also.
Yes.
Yeah, Mark?
Yeah, ready.
You had a question or you clapped?
I just clapped.
Because I can start with a question, but I can talk more. But because we work with Luis a little bit on bicycle networks, so I have a lot of questions on accessibility.
Maybe just one question.
Yes,
I'm not familiar with those processes, but there's one thing is to add roads, and another thing is to reconvert existing roads. Like what's happening in Paris right now is that they're taking like car lanes and reconverting to like half bike lanes, half car lanes. So that's so the question is, did you consider that process also in your models as a potential way to also improve even more efficiently by 0 kilometer of new road build?
Yes, the idea actually it's the one that it's happening now in Paris, because I mean when I said we're adding, at the same time it's where it can be retrofitted, so we can modify the street to convert it into half bike lane and so on. And I think now with what we're seeing in Paris and what's going on in different places around the world, because even in some places in Spain, they are doing kind of the same thing, investing a little bit more in bicycle infrastructure. Even in Mexico, where it's doing a little bit more. It can be interesting to start learning. So to develop some algorithm to learn from what's going on and what's behind that, like what kind of streets can be retrofitted to accommodate bicycles, and then to find where are these kind of streets in the city. And if we plug that together with some mobile data that we can understand how people are moving, then we can also start identifying some underused streets that can be easily reconverted. Or the other way around, if the street is underused and we want to put there a bike lane, probably it's not going to be used, because if it's not used now by cars, it means that probably it's a, I don't know, it's not a direct connection between point A and point B, or from the origin destinations. So, and I think that can be, it's an interesting problem to start thinking about it.
You're muted, Liba.
Yeah, you mentioned that you were working with the stakeholders, right? In Mexico, was it, or was it?
No, that's for the Budapest project.
Ah, it was for Budapest. Okay. So what was the main challenge there?
The main challenge there was to accommodate the different views, and also I think that's the main challenge at the end. It's that we delivered something, the government started implementing it, and then we have some elections, and the incumbent lost, and the new administration, I mean, it was a bad news, but it was also a good news, because the incumbent was from the Fidesz party, and if you're aware of the political situation in Hungary, so that was affiliated with Orban, that's the Orban party. So they lost, and now we have a more liberal government in Budapest, so that's a good thing. but then, yeah, there's some discontinuity between governments and policies and so on. So that's something that was a challenge.
Yeah, but it was a project which was designed like this, right? Like to be with stakeholders. So it was not researchers who were reaching stakeholders, but kind of stakeholders reaching.
No, yeah, exactly. Yeah, that was the way, and that was quite interesting to yeah. And then at the end, we decided, okay, if we have these results, then we should do some paper together, and yeah, we put everything into a paper form and we published. But first, the first deliverable was some public policy ideas and maps and data to inform the government for their processes.
Are there any questions or comments or suggestions? Because I know that in City Lab, people are working a lot with bikes data also. And I guess that it's always a question of whether data are also always available or what you analyze, we should analyze. So I think that if there are any no more questions, we can move to the Luis, and move to the next talk slowly, so that we have a bit of time also for yeah, Matthias, yeah, you have a question or you just clap?
Yeah. Thank you for really getting this opportunity to try to raise these questions. Is especially it is on the bike, on the issue of bike. I don't know. Is there any philosophy behind the bike, or it is just the normal bike we are talking about? And if that is it really trying? I can't understand exactly about it specifically, and I would love to know if possible.
Sorry. So if I understand correctly, it's like if there's some philosophical idea behind the bike paths and.
Yeah, what I mean is because the bike, I couldn't understand clearly if the bike you are talking of the normal bike, the then the one which is being ridden by individuals, or there is something it meant by the bike as per your presentation.
So by the bike, we think about the bicycle infrastructure as all the designated areas for bicycles. So in this case, well, the one that I presented, it's just for completely segregated bike lanes and painted bike lanes, and then we also. For the paper, we also implement the study for the 30 kilometers hours and for this kind of yeah, friendly bicycle streets in the city.
Yeah, but we can make the talk available afterwards if Luis is fine for you, and we can come back
Yes.
to it later. It's okay, Matthias? We can move forward, right? Because we